So which of these problems here are computer problems? So let's just check the 3 rules. First one, given an essay by a student, that is definitely a finite string using a constant number of symbols. So rule 1 here is okay. Does that essay have at least 10,000 characters? Well, the output is saying either yes or no, so that is easily fulfillable. And of course, the answer here is also objectively correct. You can easily count the number of characters and say, yes, it's at least 10,000 or no, it's not. So this is definitely a computer problem. The second one, of course, well, the output would still be a finite string, because you could say, depending on the grading system, A, B, C, D, or 1, 2, 3, 4. Of course, the output is not objectively correct, because different instructors tend to sometimes at least disagree on the grade that an essay deserves. So this is not a computer problem, although there have been attempts for automated grading, which is just weird, to say the least. Does the essay contain any misspelled words? Now, this is a tricky one. So the input again is finite. The output basically just says yes or no, or it can even specify the word. The problem is that it's sometimes very hard to say if something is a spelling mistake. I'll give you one example. Consider, for example, this sentence here. He was attacked by a rat. At first sight, this sentence, at least if I've written it in the correct way, does not contain any misspelled words. But actually it could contain a misspelled word, because what if the author actually had meant to type, he was attacked by a bat? That sentence by itself might make perfect sense, but you could still have simply mistyped this word here. Although, of course, your computer has a spell checker, even you might have noticed that the spell checker sometimes is wrong, because it sometimes just cannot figure out in which context you're saying your sentence. And even if it were a very, very strong computer, in this example here, you cannot objectively determine if this is the right answer. It can be dependent more or less totally on the author. This problem here is actually not a computer problem in the way that it's stated here. But this was a bit of a tricky one, so I hope you're not frustrated if you didn't get that. But it tells you that sometimes you have to watch out very carefully with these rules. They sound very simple, but actually there's some tricky details hidden in here. So let's go to the next set of problems. Given 2 integers, what is their sum? That, of course, is a very classic computer problem. The integers are given as numbers, 1, 2, 3, 4, 5. The output is a number. That's also fine. It's finite. And adding is something where you can definitely have a definitive and objective answer. Does the smaller integer divide the larger one? Yes, absolutely a computer problem. The answer is yes or no, and you can objectively say if the answer is correct or no. This one down here is not a computer problem. And actually it's not a computer problem for 2 reasons. One reason, which is a bit technical, is the RAM computer or a normal computer doesn't really have true randomness. A normal computer generates numbers that seem like random using an algorithm, but that is not random. But as I said, this is a bit technical. I think the main reason why this is not a computer problem is that it's not possible, once you have the answer, to actually know if this answer is correct. So if the number was indeed generated at random. So let me give you one example. So for example, I have the numbers 7 and 10. And now I say that I have randomly generated a 9, which lies between the 2. You have no way of checking if I really generated this number using coin flips or throwing a dice, or if I just made that up. Or maybe if I used an algorithm that always outputs a 9. So there's no way to determine from an output if that output has really been generated using a random process. And that is basically also the same reason why this one here is not correct. Of course, you can kind of determine the likelihood. If this is a very long string of zeros and ones, you can say, well, this looks more or less like a random string or not random string. But actually, if the string is generated choosing uniformly between zeros and ones, any string is as likely as any other string. So it's not possible to objectively check the answer here. So for example, if I say I generated a string using a number of coin flips and I have heads, 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 it might not look random, but maybe I was just lucky at that moment. Now the final answer here. And if you got that right without checking this answer video, then you're almost a master of theoretical computer science, because this again is a quite tricky one in my mind. I will tell you that this is not a computer problem. Why is that not a computer problem? You can enter square root of 5 into your computer. Usually you do it like this, into Google, for example, and it will tell you that the square root of 5 is 2.236066798. But that is actually not the correct answer. For example, if I enter it into another calculator or web page that has more digits, then that will tell me that it's actually not 6798, but actually 2.236066797749978969640 917, 366, and so on. The square root of 5 is an infinite string. If I ask a computer to calculate the square root of 5 to within a certain precision, say I want the first 10 digits or so, then it is a computer problem. But just asking a computer to calculate the square root of 5 in this way is not correct. Why am I nitpicking you here like this? Well, the thing is this. Infinities will play a very important role here in this unit when it comes to problems that no computer can ever solve. This is why it's very important to make sure that the input is finite and the output is finite. So if you do not make this sure or phrase the question here very precisely, then some of the results will change or not be correct. So it's very important to ensure finiteness. And later in this unit you will see why it's so important.